Then for time series, we added a lot of new improvements as well. Now in the COVID situation, people are asking for, can you predict the COVID spread itself, right? And one of the many ways we can do that is by using a epidemic model that doesn't just remember the past, Christmas sales, some kind of a stationary, repeatable thing that happens every Christmas. This is different. This grows in some fashion, and this curve, how it grows, is governed by these differential equations here that are physics, right? They're saying, if you tell me how much the growth is from infected people to people who are, potentially able to, get infected, and this is the spread rate, then this is how it will grow. And then people who are sick, they stop being sick for one or many reasons, and then that is another conversion rate, and so on. And then people who recover will for some amount of time not be infectious, and so on. All these things, they add up to this overall system of equations, and we integrate that up over time given your original data here, and we predict that this is the future of the evolution given the parameters here. But these parameters we also have to first find, like what's the spread and so on. Now, if you give us tight bounds that you can actually customize, you can say, I want the spread rate to be exactly this much, then we have less freedom to choose, right? Then it becomes your model. Otherwise, we will optimize the best parameters based on a SciPy optimizer. So you can give us as tight bounds as you want if you're an expert in epidemiology. Otherwise, you'll just say run with defaults. It will predict something. This curve that it predicts, it will subtract from the actual signal, and it will give the residuals, the remaining signal, to the model and say, XGBoost, now globally look at all the countries, subtract their trend, and then fit a residual model. So we do this trend fitting on each group in the time series world. Let's say if you have a data set with many separate time series, we automatically detect those and make a fit for each of them, subtract it, and then fit a global model. And there are other models, constant linear logistic and so on. It doesn't have to be this epidemic model, but basically time series got a lot smarter.